let's talk about probability. So first, what does probability mean? Well, we like to start by kind of talking about randomness first. So let's say we want to toss a fair coin. So to start with, could you predict whether I will get a head or tail when I flip a coin? Well, no. Before you flip it, you don't know if it's going to be head or tail. But could you predict how many heads I'd get if I flipped a coin 1,000 times? Well, if it's a fair coin, I should get about half heads, half tails, so I should get about 500 heads and 500 tails. So let's use this coin tossing applet to simulate tossing a fair coin. And let's try and toss it like 1 time or 10 times, etc. So in my applet, I can set the number of flips, it's really hard to see here, to 1 flip. Use your arrow key for better control. I can flip the coin, and it looks like I got heads. So for 1 toss, I got 1 head, so that would be 100% heads. Let's go back to my applet and try again. Let's flip the coin again, and I got tails. So this time I got 0 heads, so 0% heads. So it seems like if I'm only flipping 1 coin, the percentage of heads is going to change a lot. So see here in red, it puts percentage of heads. So we're at 100%, 0%, 100, 0. It's kind of hard to predict how many heads you'll get, right? It just seems to change a lot. But what if we move this to 10? Okay, so let's flip the coin 10 times. It looks like we got 2 heads for 20%. So 2 heads, that would be 20%. Let's try again. We got 5 heads, so 50%. And one more time. Once again, we got 5 heads. But if I tried again, I might get 3 heads for 30%. Or 3 heads, or 4 heads, or 3 heads, or 6 heads. Notice it still seems to be changing quite a bit. So this one, I had 70 heads, or 7 heads, so 70%. Let's see what happens as we increase our number. So let's make more flips. Let's try around like 360. So now it says I flip it now. Look at the percentage of heads. We're at 51, 54, 48, 46. So we still have a little bit of variation. 45, 49, but not very much. And if I put it as high as it'll go to 1,000, notice that we're very close to about half. 52, 49, 48. So we're not quite at half. We still have some variability. Oh, this time we did get exactly half. If I made this even higher to 1 billion coin flips, then it would be right there at 50% every time. So let's look at what we have here. When I tried it 20 times, I was at 45%, 35, 70, so we saw a lot of variability. At 100 times though, I'm at 55, 51, 45, 48, so still some variability. At 1,000 times, I was at 40%. I managed to do it on my own to almost 10,000 and got 50.0055%. So what do we notice here? So the more times we flip the coin, the closer we get to 50%. Let's make this the expected value of 50%. So we can't really predict what will happen on a single time, but if we do something many, many times, we can kind of realize like what a theoretical percentage should be. Now, just as a note, what would be a fair coin? A fair coin means that 50% heads, 50% tails, or each one is equally likely. So random, something is random if your individual outcomes are uncertain. So when I toss the coin 1 time, I don't know what will happen. But we can often predict the distribution of outcomes. We can predict how many heads we'll get if we do it many, many times. So we know if we're going to do this millions of times, we should get about 50% heads. Probability is the probability of an outcome is the number that measures the chance or likelihood that the outcome will occur. So the probability of an outcome is the proportion of times the outcome would occur if we observed the random process an infinite number of times. So the true probability of getting heads on a fair coin, it's 50% because we would have to observe it. If we did it many, many times or infinitely many times, we'd get 50% heads. The law of large numbers is what we wrote up above. It's as you increase the number of trials, the actual proportion of times the outcome happens gets closer to the theoretical probability. So the more times we toss the coin, the closer we get to 50%.